Hey guys, quick biochemistry basics here. Let's talk about inductively coupled plasma emission spectroscopy. As the name suggests, this technique uses plasma for the detection of elements. The device consists of a quartz tube around which radio frequency induction coil is arranged. When the electric current is passed through the RF coil, it generates a magnetic field. This current is usually an alternating current with high frequency. As the current is oscillating because of AC current, the magnetic field also oscillates. The quartz tube is attached with a source of argon gas. When the argon gas passing through the quartz tube is sparked, it generates argon ions. These argon ions are positively charged. Now remember, in physics, a charged particle in motion is easily deflected by the presence of external magnetic field. Same thing happens here. The oscillating magnetic field generated by the RF coil causes positively charged argon ions to move in a circular path. Since the magnetic field is oscillated at high frequency, the argon ions will have high velocity while moving in a circular path. During this process, the argon ions will collide with other argon atoms and generate more argon ions. This ionized gas is known as plasma. The plasma is the fourth state of matter. Since the plasma is generated by the induction of RF coil, we use the term inductively coupled plasma emission spectroscopy. The temperature of this plasma is about 6000 degrees Kelvin, which is same as the surface temperature of Sun. The sample which is to be analyzed is introduced in the nebulizer using a pump. Using argon gas, the nebulizer sprays the sample molecules in the spray chamber. This aerosol is then allowed to enter the quartz tube that has plasma. Because of high temperature of plasma, the atoms present in the sample gets excited and emits radiation of specific wavelength. The emitted light is passed through the prism and finally detected using a detector system attached with a computer. Since different atoms present in the sample have different emission spectra, they can be easily detected and distinguished using this method. Now let's say this question is asked in your exam. So here is what you can do. First, draw the schematic diagram. Next, explain the principle. Explain how this technique uses plasma to excite the sample molecules. The excited sample molecules emits radiation, which is also known as emission spectra, and based on this emission spectra, we detect the sample. Then you can explain about the working mechanism, explain about the role of RF coil, explain how plasma is generated, and finally explain how emission spectra is generated and detected.